Hello everyone. Today let us continue with session 9 in the learning management system. We are going to continue in today's class the review of modern periodic table, classification of elements based on electronic configuration. There were many periodic tables which were given right from the beginning. Let us continue with the little bit latest one, that is Mendeleev's periodic law, which was given actually after Duvernier's, then Newland's, and then came Mendeleev's. So Mendeleev had arranged the then known elements, based on the increasing order of their atomic mass. So his periodic law states that the properties of the elements are the periodic function of their atomic mass. Then we see this is the Mendeleev's periodic table, which was based on the increasing order of their atomic mass. Then later on, a modern periodic law was given, and this was based on the increasing order of their atomic number. This the modern periodic law states that the elements are arranged in the increasing order of their atomic number. Now we have the long form of periodic table where the elements are arranged based on their electronic configuration. That is, in each element, in the last electron or the differentiating electron is entering into the which orbital. So based on this, we have the long form of periodic table. So the long form of periodic table is mainly based on the electronic configuration, and we can classify now based on the differentiating electron entering into the orbitals as S, P, D and F block. The main cause of periodicity is due to the electronic configuration. So the elements, the cause of periodicity is going to be the properties are repetition. The properties are repetition due to the similar outer electronic configuration at certain regular intervals. Coming to now the classification of elements into S, P, D and F block elements based on the type of atomic orbitals which receives the last electron or the differentiating electron. The elements are categorized as S, P, D and F block. So this is going to be the S block elements. All the elements in this block will receive the last electron or the valence electron in the S orbital. And in this one, to the extreme right of the periodic table, we observe the elements receive their valence electron in the p orbitals. And in between the S and P block, we are having the D block elements. We receive the last electron in the D orbitals. And at the bottom of the periodic table, we have the F block elements. The elements in this group receive the differentiating electron in the F orbitals. Coming to the S block elements, the last electron in this block elements will enter the S orbital. They are going to enter the S orbital. Here, the last electron in this block elements will enter into the S orbital. The alkali metals of group 1, this is group 1 and this is going to be group 2. So these two block elements come under S block elements. These elements, the elements in S block elements, the elements in the S block are usually soft. They have low melting and boiling points. They have got low melting and boiling points. They have low melting point as well as boiling point. They have low ionization enthalpies. They lose their outermost electron. They lose their outermost electron to form uni-positive. They usually form uni-positive and dipositive ions. So uni-positive in case of alkali metals and dipositive. So S block elements usually exhibit +1 and +2 oxidation state because in this block elements the electrons are present in the electrons are received in their outermost shell in the s orbital, and they can lose their electrons from the outermost shell. So they usually form alkali metals form +1 oxidation state and alkaline earth metals form +2 oxidation state. Coming to the p block elements are placed to the extreme right in the periodic table. So the last electron are entering into the p orbitals in the outermost shell. And the electronic configuration usually varies from Ns2Np1 to Ns2Np6. At the end of the period of the noble, there is a noble gas element with a stable configuration of Ns2Np, Np2. So at the end of the period in P block elements, we observe we are having stable gas configuration, or that is we have got neon, argon, krypton, xenon and radon. The P block elements are usually metals. They are going to be non-metals and they are metalloids. The P block elements form compounds by losing or gaining an electron or by sharing. So the P block elements form compounds either by loss, gain or by sharing of the valence electron. So they can form both ionic as well as covalent bonds. P block elements can form both ionic as well as covalent bonds. They readily gain one or two electrons to attain stable noble gas configuration, that is Ns2Np6. So in P block elements, the valence electron or the differentiating electrons are entering into the p orbitals. They have the general electronic configuration from Ns2Np1 to Ns2Np6. They are usually metals, non-metals and metalloids. They form compounds by loss, gain or sharing of electrons to attain stable electronic configuration. Next, coming to the D block elements. In D block elements are placed between the S and P block. So these block elements are called as D block elements. The main reason is because the differentiating electron or the valence electron are received in the d orbitals of the element. So the elements belonging to group 3 to 12 in the periodic table are called as D block elements. So from group 3 to group 12 are called as D block elements. The differentiating electrons are not received in the outermost shell, but they are received in the penultimate shell. Here the electrons are received in the penultimate shell, that is the last one shell. These elements have an outermost electronic configuration of N-1, D 1 to 10 and Ns 1 or 2. The D block elements are placed between S and P block. They exhibit translational or intermediate behavior between the most active metals in S block and less active metals in the P block. Hence, they are called as transition elements. Next, coming to the F block elements. The F block elements are placed at the bottom of the periodic table. We observe they are present at the bottom of the periodic table. The F block elements receive their last electron into the f orbitals. They are going to receive the last electrons in the f orbitals, and they exhibit the outer configuration as n minus 2 F 1 to 14, n minus 1 D 0 or 1 and ns 2. Here these electrons are received in the antipenultimate shell. In s block elements, the electrons are received in the last shell. In f block elements, the electrons are received in the antipenultimate shell or the inner to the penultimate shell. N minus 2 shells, these elements are called as inner transition elements because the electrons are received in the n minus 2 shell. They are called as inner transition elements. So in F block elements, we are having two series. One is the lanthanide series and the actinide series. When 4f orbitals are filled up, they are called as lanthanide series. And when the 5f orbitals are filled, they are called as actinides. The inner transition elements also form colored compounds in variable oxidation state. They usually have the common oxidation state as +3. So, in F block elements, the electrons are received in the f orbitals of the antipenultimate shell. So, the references here which are taken from Inorganic Chemistry by Puri Sharma and Kalia. Thank you.